we're going to finish up the example that we started in our last video by looking at the final two steps of our problem solving process here. So just to kind of remember where we left off, we came up with the equation that relates all of our variables, which was a squared plus b squared equals c squared. And we had this really nice picture up here. I'm going to try and highlight it. This really nice picture right here that gave a good illustration of what's going on. It organized all of the important information, and it's just going to make actually the last part of this problem much, much easier for us to work with. So, step 5 of our problem solving process, once we have our equation, we want to take the derivative of that equation with respect to time t. This part's really, really important. The reminder here that I'm going to give is that we're using implicit differentiation. You can also think about it as the chain rule here. So I'm going to take the derivative of a squared plus b squared equals c squared. I'm going to be taking the derivative of this equation with respect to time. So I'm going to have d over dt. This says I want to take the derivative with respect to t, because all of these sides, everything in my problem is changing with respect to time. I can go back and look. Here we said, if I look at the rate that I have highlighted here, we said feet per second, per unit of time. It's changing with respect to how many seconds have passed. So I want to take the derivative of this equation with respect to time. So I'm going to have to use implicit differentiation here. Now the derivative of a squared, that would be 2a, but a is a function of time. I'm going to have to use implicit differentiation, so I need to multiply by the derivative of a with respect to t. So you can either write that as dA over dt, or you can write that as 2a times a prime, just depending on your preferred derivative notation. Again, I prefer dA over dt because I think it is a lot more helpful to remember that we're taking the derivative with respect to time, and it can be helpful when remembering our units. But if you want to use a prime and you're more comfortable with that, then go ahead and continue to do that. So next, I need the derivative of b squared. Using our power rule, we'll have 2b, but the derivative of b with respect to time t, I need to multiply by that, so db over dt for my implicit differentiation. And then the derivative of c squared, well, that's going to be 2c, but again, I'm taking the derivative with respect to time. C is a function of time, so that means I need to multiply by dc over dt. So your equation, your derivative, excuse me, will either look like 2a times dA over dt plus 2b times dB over dt is equal to 2c times dc over dt. If you prefer the prime notation, you can say 2a times a prime plus 2b times b prime is equal to 2c times c prime. Neither notation is necessarily right or wrong. Everyone's just going to have their own personal preference. I'm going to use that top derivative though. So this is all I really need to do in this step is to take the derivative, and once I have that, we can move on to our final step, step 6, which now we are actually going to go ahead and solve for the missing rate. We're finally in a position where we can solve for what it is that the problem was asking for. So I have this derivative right here. And actually, I'm going to bring this down. I'm going to copy this down here. I have this derivative that, okay, everything is, it's A dA over dt, B dB over dt. There's a lot going on here. But if I look at the picture that I drew earlier, this has everything that we will need here. If I look at, here's A is equal to 24. Here's dA over dt. We said that's -2. Here's B. We said B was 10. dB over dt, we don't know what that is, but that's going to be what we solve for, so that's okay. Here's C is equal to 26, and dC over dt is equal to 0. So I'm going to take all of that relevant information and plug that into my derivative. So let's see, we'll have 2 times A, which I already forgot what A is. A is 24, times dA over dt. Let's see, dA over dt, we said that was -2. Plus 2b, we said b was 10. Now dB over dt, we don't know what that is. That's going to be what we're solving for. So I'm going to actually leave that as dB over dt is equal to 2c, we said c was 26. And then dC over dt, we said that was 0 because the length of our ladder is not changing. So this is the equation now that I'm going to solve. I'm going to solve for dB over dt. And at this point, actually, we're pretty much done with the calculus part until we come and interpret our answer here. But if I want to just think about the steps I'm going to have to take, it's all algebra after this. There's really not any more derivatives or calculus. It's just going to be, multiplying some numbers and solving for a variable. So I'm going to take 2 times 24 times -2. Here I should have -96 plus 2 times 10. That's going to be 20 times dB over dt. I'm going to treat this like a variable. Even though it's a derivative, I'm just treating it like it's a variable. You can put x in its place if you want to. On the other side of my equation, 2 times 26 times 0, well, that's just going to be 0. So let's see, if I want to solve this equation, we'll add 96 to each side. So 20 dB over dt is equal to 96. So that means that dB over dt is going to be 96 divided by 20. Or if I divide that out, I have 4.8. Now, I like to include a unit with my answer here. dB, how is B measured? Well, B was the distance between the wall and the ladder, and I can actually look. Here we said 10 feet away from the wall. So the unit of B would be feet, 4.8 feet per what? Per unit of time. And I can look, well, we said we were measuring in terms of seconds. So that means 4.8 feet per second. I can actually even say a little bit more if I wanted to. I can look at the sign of this and say, well, side B, because we ended up with a positive 4.8 feet per second, we can actually say that the side B is increasing by 4.8 feet per second at this particular moment in time because we ended up with the positive. And that actually matches exactly what we said was happening with our picture. We said, remember, let me erase some of this highlighting so it's easier to see. We said earlier that this side was going to be moving to the right, which means that B, this side of my triangle, is going to get longer. So that matches up exactly with what we said would happen. So once you have your equation, all we need to do is take our derivative and then plug in the information that we so neatly organized at the beginning of our problem into our derivative and then solve for that missing piece of information. I would suggest including a unit with all of your answers. It is something that I'm going to be looking for on quizzes and exams. So please remember to do that. I will continue to do that as we work through the rest of our examples.